Hello there, and welcome to Worlds Beyond Seen. As you settle in tonight, perhaps with the world growing quiet around you, we're going to explore a question that sits at the very edge of what we can know about our past. A question that whispers through archaeological sites and echoes in myths passed down through countless generations. What if, during the last great transition of our planet's climate, something profound was lost? Before we begin this journey into deep time, I'd like to invite you to tap the like button and subscribe to the channel. Your support helps more curious minds find their way to these explorations, and it means the world to me. No pressure, of course, just an invitation, like the faint trail of footprints we'll be following tonight, leading us into mysteries that have waited thousands of years to be understood. Now, let's slow our breathing, relax into this moment, and step backward in time, not just a few centuries, but thousands of years, to an age when the world was fundamentally different, when ice sheets covered vast portions of the northern hemisphere, when sea levels stood more than 120 meters lower than they do today, when coastlines extended far beyond their current boundaries, and lands now beneath the waves were home to people who lived, loved, created, and perhaps knew things we have forgotten. Tonight, we're investigating whether sophisticated hunter-gatherer societies, with complex knowledge systems and remarkable cultural achievements, were lost during the rapid climate changes at the end of the last ice age. We're not talking about primitive cave dwellers struggling to survive. We're talking about people who may have possessed deep understanding of astronomy, sophisticated architectural knowledge, complex social structures, and traditions that encoded wisdom gathered over countless generations. People who, when faced with catastrophic environmental changes, may have seen their entire world swept away by rising waters, buried beneath advancing ice, or consumed by the chaos of a planet in transition. And the haunting question is, how much did we lose? How much knowledge? How much sophistication? How much human achievement vanished in those tumultuous centuries when the Ice Age released its grip on the world? Let's begin by understanding the stage on which this drama played out, the world of the late Ice Age, and the remarkable changes that transformed it. The stage, the world of the late Ice Age. Picture Earth as it was 20,000 years ago, at the peak of what scientists call the last glacial maximum. This was a planet dramatically different from the one we know. Ice sheets stretched across continents like frozen oceans, some more than 2 miles thick. The Laurentide ice sheet blanketed much of North America, from the Arctic down to what is now the northern United States. The Fennoscandian ice sheet covered Scandinavia and pushed south into northern Europe. Smaller glaciers crowned mountain ranges around the world. But ice was not the only feature of this transformed world. With so much water locked up in these continental glaciers, sea levels stood approximately 120 meters lower than today. This single fact reshaped the entire geography of Earth. Coastlines extended far out onto what are now continental shelves. Land bridges connected regions that today are separated by water. The world had more terrestrial surface area, and crucially, some of the most productive, resource-rich lands existed in coastal zones that are now completely submerged. Between the ice sheets and the modern-day coasts lay vast expanses of tundra and what scientists call the Mammoth Steppe, an ecosystem unlike anything existing today. This was cold, dry grassland that stretched from Western Europe through Siberia and across the Bering Land Bridge into North America. Despite the harsh conditions, this environment was astonishingly productive, supporting enormous populations of megafauna, mammoths, mastodons, woolly rhinoceroses, giant ground sloths, saber-toothed cats, cave lions, dire wolves, and countless other species. The climate was not uniformly frigid. While the regions near the ice sheets experienced brutal cold, areas farther south enjoyed cooler but still temperate conditions. Importantly, many coastal areas, now submerged, would have offered remarkably favorable conditions for human habitation. Protected river valleys, estuaries, marshlands, and coastal plains provided abundant resources. Fish from rivers and shallow seas, migratory birds, shellfish, edible plants, and game animals following seasonal patterns. In this world lived our ancestors, fully modern humans, Homo sapiens, who had been spreading across the globe for tens of thousands of years. By 20,000 years ago, humans had reached virtually every habitable continent. They lived in the shadow of the ice sheets, on the mammoth steppe, along now vanished coastlines, and in warmer regions farther south. These were not primitive beings. Their brains were no smaller than ours. Their capacity for innovation, abstraction, art, and complex thought was identical to our own. Archaeological evidence reveals sophisticated behaviors. Humans of this period created remarkable art. The famous cave paintings of Lascaux and Altamira, carved figurines, musical instruments made from bone, and intricate personal adornments. They had complex social structures, engaged in long-distance trade materials like shells and stones are found hundreds of miles from their sources, practiced elaborate burial rituals, suggesting belief systems and concepts of an afterlife, and demonstrated advanced hunting strategies, requiring cooperation and forward planning. Tool technologies had become increasingly refined. While we call this the Stone Age, the term understates the sophistication involved. Creating an effective stone blade or spear point requires deep understanding of stone properties, precise techniques passed down through generations, and considerable skill. These people also worked bone, antler, wood, plant fibers, and likely many organic materials that have not survived in the archaeological record. But here's what's crucial for our investigation. We know about these people primarily from sites that survived, sites on dry land that remained dry, or sites in caves where conditions preserved materials. What we know is biased toward what survived, and when we consider that the most productive, resource-rich environments of the Ice Age were often coastal areas that are now beneath 120 meters of water, we face a sobering reality. We may be missing vast chapters of human achievement. Imagine if the productive, population-dense coastal areas of today, regions like the eastern United States seaboard, the coast of Japan, or the Mediterranean, were suddenly flooded and lost beneath the ocean. Future archaeologists would have a dramatically incomplete picture of our civilization. They might find some inland sites, but they would miss the major population centers, the places where innovation concentrated, where trade networks converged, where cultural sophistication reached its peaks. This is precisely the situation we face when studying Ice Age humanity. The archaeological record is incomplete, fundamentally and irrevocably incomplete, because the areas where humans may have achieved their greatest sophistication are now underwater, buried beneath meters of marine sediment, effectively sealed off from easy investigation. As the Ice Age progressed toward its end, starting around 15,000 years ago, the climate began to shift. Temperatures rose, ice sheets started their long, irregular retreat. But this was not a smooth transition. The climate lurched between warmer and colder periods, sometimes shifting dramatically over just decades or even years. Sea levels began to rise, slowly at first, then more rapidly as melting accelerated. And into this unstable world, humans had to adapt. Some populations migrated, following the shifting boundaries of favorable environments. Others may have stayed in place, watching their world transform around them. Coastal communities would have faced an inexorable reality. The sea was advancing, not in a single catastrophic flood, though those did occur, but in a relentless, generation-by-generation encroachment that gradually swallowed ancestral lands, sacred sites, hunting grounds, and settlements. By 10,000 years ago, sea levels had risen substantially, though they still stood lower than today. Major land bridges like Beringia, connecting Asia to North America, were flooded. Doggerland, the vast plain connecting Britain to continental Europe, had become an archipelago of islands. The Persian Gulf was filling with water, drowning what had been a river valley. Similar stories played out on every coast around the world. And then, around 12,800 years ago, something extraordinary happened. The climate, which had been warming, suddenly plunged back into near glacial conditions. This event, known as the Younger Dryas, lasted approximately 1,200 years and represented a dramatic reversal of the warming trend. Temperatures dropped sharply, glaciers advanced again, and ecosystems worldwide were disrupted. When the Younger Dryas ended, around 11,600 years ago, the warming resumed with even greater intensity. This period of rapid climate change, from roughly 15,000 to 10,000 years ago, was perhaps the most dramatic environmental transformation that modern humans have ever experienced. And it's during this exact window that we see major changes in the archaeological record: the disappearance of many Ice Age megafauna species, significant shifts in human tool technologies and cultural patterns, the emergence of early agriculture in several regions, and, potentially, the loss of sophisticated coastal societies. The question we're exploring tonight is whether this transformation erased not just lands and ecosystems, but also human knowledge, cultures, and societies that had reached levels of sophistication we have yet to recognize. Let's examine the evidence for such sophistication, evidence of sophisticated Stone Age cultures. When we think of Stone Age hunter-gatherers, stereotypes often dominate. We imagine small bands wandering constantly, living hand-to-mouth, focused entirely on basic survival. This image has been powerfully revised by archaeological discoveries over the past few decades. The reality was far more complex, varied, and in many cases, surprisingly sophisticated. Consider Göbekli Tepe in southeastern Turkey. When this site was properly excavated starting in the mid-1990s, it revolutionized our understanding of what hunter-gatherers could achieve. Göbekli Tepe consists of massive circular structures built from T-shaped limestone pillars, some standing over 5 meters tall and weighing up to 50 tons. These structures are decorated with intricate carvings of animals, abstract symbols, and anthropomorphic figures. The craftsmanship is extraordinary. What makes Göbekli Tepe truly revolutionary is its age. Radiocarbon dating places its oldest structures between 9,500 and 8,000 BCE, firmly in the pre-pottery Neolithic period, before the development of pottery, before the widespread adoption of agriculture, and before the establishment of permanent villages in the region. The original interpretation, proposed by archaeologist Klaus Schmidt, was that Göbekli Tepe was built by mobile hunter-gatherer groups who periodically gathered for ritual purposes. The implications are staggering. The construction would have required hundreds, perhaps thousands of people. The organization, planning, and execution demanded sophisticated social structures, the ability to feed and coordinate large groups of workers, and architectural and geometric knowledge to design and construct the megalithic circles. Recent analyses have revealed that the structures were laid out using geometric patterns, specifically equilateral triangles, suggesting advanced planning before construction even began. Even more remarkable, Göbekli Tepe is not unique. Nearby sites like Karahan Tepe, Nivali Chori, and others in the same region show similar T-shaped pillars and monumental architecture from the same period. This suggests a widespread cultural tradition of monumental building among hunter-gatherer or transitional communities. These people had the organizational capacity, technical skill, and most importantly, the motivation to create structures of this scale and complexity. But architectural sophistication is just one indicator. Let's consider what such construction implies. First, complex social organization. Building monuments of this scale requires the ability to mobilize large numbers of people, coordinate their efforts, feed them during construction, and maintain social cohesion. This suggests leadership structures, possibly religious or political hierarchies, and the ability to organize collective labor. Second, specialized knowledge. The architectural and geometric precision implies the existence of individuals with specialized knowledge, essentially architects or master builders whose expertise was valued and transmitted across generations. Third, leisure time and surplus. Creating monumental architecture requires more than just survival-level subsistence. It suggests communities with sufficient food security, to allow individuals time for activities beyond immediate survival needs. Fourth, symbolic and abstract thinking. The elaborate iconography carved into the pillars represents animals, symbols, and possibly narratives. This indicates sophisticated belief systems, mythology, and the capacity to represent complex ideas in physical form. Beyond monumental architecture, there's abundant evidence of other sophisticated behaviors in late Pleistocene hunter-gatherer societies. Consider the example of the Natufian culture, which flourished in the Levant, modern-day Israel, Palestine, Lebanon, Syria, and Jordan between approximately 12,500 and 9,500 BCE. The Natufians were semi-sedentary hunter-gatherers who established some of the first permanent settlements in the region. They lived in substantial stone dwellings, created elaborate art and personal adornments, developed early technologies for grain processing. Grinding stones suggest they were collecting and processing wild cereals, and practiced complex burial rituals, including removing skulls from bodies, which suggests sophisticated beliefs about death and ancestors. The Natufian culture shows many characteristics we associate with advanced societies, including permanent architecture, social stratification, some burials are more elaborate than others, specialized tool production, and artistic traditions. Yet they were primarily hunter-gatherers, living before the agricultural revolution. Or consider the Upper Paleolithic cultures of Europe, famous for their cave art but representing much more. Sites like Dolní Věstonice in the Czech Republic, dated to approximately 29,000 years ago, have yielded thousands of artifacts, including ceramic figurines, some of the oldest ceramics in the world, though used for art rather than pottery, elaborate woven textiles, impressions preserved in clay, evidence of constructed dwellings with hearths, and indicators of long-distance trade networks. At Sungir in Russia, dated to approximately 34,000 years ago, burials have been found containing individuals covered with thousands of ivory beads. One burial is estimated to have contained more than 3,000 beads, representing thousands of hours of work. This suggests not only artistic sophistication but also social structures that valued individuals enough to invest extraordinary effort in their burials. Looking at maritime peoples, we know that humans reached Australia by at least 65,000 years ago, which required sea voyages of substantial distance, even when sea levels were lower. This demonstrates sophisticated boat-building technology, navigation skills, and the social organization to undertake such voyages. In the Americas, the Clovis culture appeared around 13,000 years ago and spread rapidly across North America, representing sophisticated big-game hunters with distinctive projectile point technology. While long thought to be the first Americans, we now know humans arrived earlier, perhaps 20,000 years ago or more, but the Clovis culture represents a technological peak in stone tool manufacture. All of these examples share common features. They demonstrate that late Pleistocene humans were capable of remarkable achievements, that hunter-gatherer societies could be far more complex than stereotypes suggest, and that sophistication didn't require agriculture or cities. Now, critically, these are the sites we've found. They're located in areas that remained above water, or in caves with excellent preservation conditions. But what about the coastlines? What about the river valleys and estuaries that are now submerged? Modern research into coastal adaptations suggests that coastal environments were likely some of the most productive for hunter-gatherer societies. Marine and estuarine resources, fish, shellfish, seabirds, seals, sea mammals, provide reliable, often abundant calories. Coastal zones often supported higher population densities than inland areas, and rivers providing access to the interior created highways for travel, trade, and communication. In short, if we wanted to find the most sophisticated, most densely populated hunter-gatherer societies of the Ice Age, the logical place to look would be the coasts, and those coasts are now underwater. The archaeological evidence strongly suggests that Ice Age hunter-gatherers were far more sophisticated than previously thought. They built monuments, created art, established long-distance trade networks, developed specialized tools and technologies, formed complex social structures, and maintained cultural traditions over thousands of years. These were not simple survival societies. These were cultures with depth, knowledge systems, and achievements that rival early agricultural civilizations in many respects. So the question becomes more pointed. If hunter-gatherers in marginal inland environments could achieve this level of sophistication, what might coastal populations, with access to more abundant and reliable resources, have achieved? And when those coastlines were flooded, when sea levels rose by 120 meters, drowning the continental shelves, what was lost? The archaeological record cannot answer this directly. The evidence is underwater, buried beneath marine sediments, largely inaccessible. But circumstantial evidence, comparative ethnography, and logical inference all suggest the same conclusion. We are missing substantial portions of human cultural achievement from the Ice Age, and some of what we're missing may have been remarkably sophisticated. But it wasn't just the slow rise of seas that threatened these societies. There was also a dramatic, sharp climate disruption that may have delivered a catastrophic blow to Ice Age civilizations. Let's examine the Younger Dryas event. The Younger Dryas, a catastrophic interruption. Around 12,800 years ago, the world was warming. The great ice sheets were in retreat. Sea levels were rising. Life was returning to lands that had been frozen for millennia. And then, abruptly, it all reversed. Temperatures plunged. Ice advanced. The warming trend that had been underway for thousands of years suddenly halted and ran backward. This event is called the Younger Dryas, and it represents one of the most dramatic and mysterious climate shifts in recent Earth history. The Younger Dryas gets its name from a small alpine flower, Dryas octopetala, which thrives in cold conditions and suddenly became common across parts of Europe as temperatures dropped. The event lasted approximately 1,200 years, from about 12,800 to 11,600 years ago, and its effects were felt globally, though most intensely in the Northern Hemisphere. The temperature drop was severe. In Greenland, average temperatures fell by approximately 15 degrees Celsius in just a few decades. That's an extraordinary shift, equivalent to plunging from a climate similar to modern Denmark's to one resembling northern Greenland. In Europe, glaciers that had been retreating began to advance again. Forests gave way to tundra. Lake levels dropped as precipitation decreased. For the people and animals living through this period, it would have been catastrophic. Imagine a world where, within your grandparents' lifetimes, the climate had been improving, forests had been expanding, game had been abundant. Then, within your parents' generation, everything reversed. The cold returned with intensity, food sources declined, the landscape transformed, survival became precarious. For much of the 20th century, scientists believed the Younger Dryas was triggered by a massive influx of fresh water into the North Atlantic, disrupting ocean circulation patterns. The leading theory was that a huge glacial lake in North America, Lake Agassiz, suddenly drained, releasing enormous volumes of fresh water that shut down the Atlantic conveyor current system, which normally carries warm water northward. Without this heat transport, the Northern Hemisphere cooled dramatically. However, recent evidence has complicated this picture. While meltwater pulses certainly occurred, the timing doesn't perfectly match the Younger Dryas onset. Additionally, the global extent of the cooling suggests something more than just a regional ocean circulation change might have been involved. Enter one of the most controversial hypotheses in recent archaeology and climate science, the Younger Dryas impact hypothesis. First proposed in 2007 by Richard Firestone, Alan West, and a team of researchers, this hypothesis suggests that the Younger Dryas was triggered not by terrestrial causes alone, but by an extraterrestrial impact, either a comet or asteroid strike, or more likely, an airburst from a cosmic object exploding in the atmosphere. According to this hypothesis, approximately 12,800 years ago, a comet fragment or fragments struck or exploded over the Northern Hemisphere, potentially over the Laurentide ice sheet. The impact or airburst would have caused massive wildfires across continents, triggered an impact winter by throwing debris into the atmosphere that blocked sunlight, destabilized the ice sheets, causing rapid meltwater pulses into the oceans, disrupted ocean circulation patterns, and contributed to the extinction of many large mammal species. The evidence cited in favor of the impact hypothesis includes several distinctive markers found in sediment layers dated to the Younger Dryas boundary. These include platinum and iridium anomalies, rare metals associated with extraterrestrial objects, found in elevated concentrations in sediments from this period, nanodiamonds, tiny diamond crystals that form under extreme pressure and temperature, consistent with impact conditions, magnetic microspherules, tiny spherical particles formed from molten material, found abundantly in Younger Dryas boundary layers, carbon-rich deposits, including widespread charcoal and soot, suggesting massive continental-scale wildfires, and glass-like carbon, indicating materials exposed to extremely high temperatures. Furthermore, the timing is striking. The Younger Dryas boundary coincides with significant extinctions of megafauna, the disappearance of the Clovis culture in North America, or at least a significant disruption, and dramatic environmental changes visible in the geological record. However, the impact hypothesis has been intensely controversial and remains debated. Critics have argued that many of the proposed impact markers can be explained by terrestrial processes, that some early findings couldn't be replicated at other sites, that no impact crater has been found, though proponents argue it would have struck ice and disappeared when the ice melted, and that the scale of wildfires proposed doesn't match the evidence. Over the years, the hypothesis has evolved. By 2020, significant new evidence had accumulated. Multiple independent studies confirmed the presence of platinum anomalies in Younger Dryas boundary layers across numerous sites, widespread soot and charcoal deposits in lake sediments, marine cores, and ice cores from 152 sites, nanodiamonds in multiple locations, and synchronous timing of these markers across geographically dispersed sites. A comprehensive 2021 review concluded that the evidence had strengthened substantially and suggested the hypothesis deserved serious consideration. Some prominent climate scientists, including Wallace Brooker, who originally proposed the ocean circulation shutdown hypothesis, eventually agreed that an extraterrestrial impact might have been the trigger that pushed an already unstable climate system over the edge. Whether or not the impact hypothesis is ultimately confirmed, what's indisputable is that the Younger Dryas was a catastrophic climate event that profoundly affected both human societies and natural ecosystems. The megafauna extinctions are particularly striking. Within a relatively short period around the Younger Dryas, many large mammal species vanished. In North America, 33 genera of large mammals went extinct, including mammoths, mastodons, giant ground sloths, saber-toothed cats, dire wolves, American lions, short-faced bears, and many others. Similar extinctions occurred in South America, Europe, and other regions. The debate over what caused these extinctions has raged for decades. Some scientists favor climate change as the primary driver, arguing that the rapid shifts between glacial and interglacial conditions disrupted habitats and food sources. Others emphasize human hunting, the overkill hypothesis, suggesting that as human populations grew and spread, they hunted these large animals to extinction. Still others propose disease, habitat fragmentation, or combinations of factors. The Younger Dryas impact hypothesis adds another possibility, that a catastrophic event simultaneously disrupted climate, triggered widespread ecological collapse, and potentially devastated human populations. If true, this would have been a truly apocalyptic scenario. Continental-scale wildfires would have destroyed vast areas of habitat, consumed food sources, and released enormous amounts of smoke into the atmosphere. An impact winter would have caused rapid cooling, crop failures for any groups beginning to cultivate plants, and starvation. Tsunamis, if the impact occurred over ocean or coastal areas, would have devastated coastal settlements, and the subsequent climate disruption would have lasted for centuries. For human societies, particularly those living in areas directly affected or dependent on now extinct megafauna, this would have been existential. Populations would have declined dramatically. Cultural continuity would have been disrupted. Knowledge systems maintained by oral tradition could have been lost as elders died before passing on information. Social structures would have collapsed under the strain. And here's a critical point. The people most likely to be affected were coastal populations. If an impact occurred over the North Atlantic or North American ice sheets, as proposed, the resulting tsunamis would have devastated Atlantic coastlines. The rapid climate shifts would have been most dramatic near the ice sheets, and the rise in sea levels, potentially accelerated by the destabilization of ice sheets, would have been particularly catastrophic for coastal communities. In other words, the very populations that likely possessed the highest levels of sophistication based in resource-rich coastal environments would have been hit hardest, not by gradual change they could adapt to, but by sudden catastrophe followed by centuries of instability. Even if the impact hypothesis proves incorrect, the Younger Dryas itself, caused by whatever mechanism, represents a dramatic disruption. A world that had been warming suddenly plunged back into cold. A climate that had been relatively stable for several thousand years became chaotic. And human populations, particularly those in marginal environments or dependent on specific resources, would have faced tremendous challenges. When the Younger Dryas ended, around 11,600 years ago, the warming resumed with intensity. Temperatures rose, ice melted rapidly, sea levels resumed their rise, and the world entered the Holocene, the current geological epoch, characterized by relatively stable, warm conditions. But the world that emerged from the Younger Dryas was different from the one that entered it. Many megafauna species were gone, human populations had been disrupted, relocated, and reduced. Cultural patterns had shifted, and vast coastal areas had been, or soon would be, inundated by rising seas. If sophisticated coastal societies existed before the Younger Dryas, this event and its aftermath may have delivered a fatal blow. The immediate catastrophe, if there was an impact, the centuries of climate instability during the Younger Dryas, the subsequent rapid warming and sea level rise, and the loss of familiar territories and resources could have erased entire cultural traditions, knowledge systems, and populations. The question isn't whether some humans survived. Obviously they did. We're here. The question is what was lost. What knowledge, what achievements, what sophistication vanished in this tumultuous period? To approach this question, we need to consider what kinds of knowledge systems Ice Age societies might have possessed. Lost knowledge systems. What might have been forgotten? When we think about knowledge in pre-literate societies, we often underestimate its depth and complexity. Without writing, we assume, how much could they really know? But this assumption betrays a bias toward literate cultures. In fact, oral societies have demonstrated remarkable capacities for preserving, transmitting, and accumulating knowledge across generations. And there's good reason to believe Ice Age hunter-gatherers possessed sophisticated knowledge systems that were lost when their societies were disrupted. Let's start with astronomical knowledge. Many hunter-gatherer societies possess detailed astronomical knowledge used for navigation, timekeeping, and cultural purposes. Aboriginal Australians, for example, have maintained astronomical traditions for tens of thousands of years, encoding detailed observations of stars, planets, and celestial events in oral traditions. Some of their star knowledge includes recognition of variable stars whose brightness changes over time, understanding of planetary motions, and observations of stellar objects like the Magellanic Clouds, dwarf galaxies visible from the southern hemisphere, integrated into mythology and navigation systems. There's evidence suggesting Ice Age peoples possessed similar knowledge. Some cave paintings may represent stellar configurations. Bone artifacts with regular markings have been interpreted as lunar calendars, tracking the phases of the moon. More controversially, Some researchers have argued that certain megalithic structures from the later Neolithic encode astronomical alignments, and that this knowledge must have derived from earlier traditions. Consider what astronomical knowledge would mean for a society. It provides accurate calendars for tracking seasons, crucial for knowing when to hunt migratory animals, when plants would fruit, and when weather patterns would shift. It enables navigation, allowing long-distance travel with the ability to find one's way back. And it offers a framework for understanding the cosmos, contributing to cosmological beliefs, mythology, and cultural identity. If coastal Ice Age societies possess sophisticated astronomical knowledge, developed over thousands of years of observation, this knowledge would have been encoded in oral traditions, physical markers, or mnemonic devices. When catastrophe struck, when populations were scattered, reduced, or relocated, when elders died before passing on traditions, this knowledge could have been lost. We would never know it existed. Consider also ecological knowledge. Hunter-gatherer societies typically possess encyclopedic knowledge of their environments. They know hundreds or thousands of plant species, which are edible, which are medicinal, which are poisonous, and how to process them. They understand animal behavior, migration patterns, breeding cycles, and habitat preferences. They recognize ecological relationships, how different species interact, how weather affects plant growth, and how to read environmental signs. This knowledge is not casual or superficial. It represents the accumulated observations of countless generations. Modern ethnographic studies of hunter-gatherer groups have revealed the depth of this knowledge. Amazon peoples can identify and use hundreds of plant species. Arctic peoples possess detailed knowledge of ice conditions, weather patterns, and animal behavior that has proven more accurate than modern scientific predictions in some cases. For Ice Age coastal societies, this knowledge would have been especially rich. Marine and estuarine environments are complex, with tidal patterns, seasonal migrations of fish and birds, shellfish beds, and the intricate ecology of marshlands and deltas. Mastering these environments would have required deep, detailed knowledge passed down across generations. When sea levels rose, when coastlines shifted dramatically, this knowledge became partially or entirely obsolete. The specific locations, the landmarks, the ecological details, all would have been submerged. New coastlines would require new learning. But if the transition was too rapid, if populations were scattered or reduced, if the elders who held the knowledge died in catastrophes, the depth of that knowledge system could be lost. Think about medicinal knowledge specifically. Many hunter-gatherer societies possess sophisticated understanding of plant medicines. They know which plants treat infections, reduce pain, aid digestion, induce or prevent pregnancy, and address various ailments. This knowledge represents experimentation over generations, careful observation of effects, and transmission of successful treatments. If sophisticated Ice Age societies developed extensive pharmacopoeias, this knowledge would have been entirely oral. There would be no written record. If the societies were disrupted, if the specialists who held this knowledge died, if the plants they used grew in now submerged coastal zones and were no longer accessible, the knowledge would simply vanish. We would never know it existed, yet its loss would represent a genuine setback for human knowledge. Consider navigational knowledge. We know ancient peoples were capable of remarkable feats of navigation. Polynesians colonized the Pacific Islands, traveling thousands of miles across open ocean using stars, wave patterns, bird behavior, and other environmental cues. This required not just courage but also sophisticated knowledge systems, detailed mental maps, understanding of currents and winds, ability to read subtle environmental signs, and traditions for transmitting this knowledge. If Ice Age coastal peoples engaged in long-distance maritime travel, if they had detailed knowledge of currents, seasonal patterns, and navigation techniques, this knowledge would have been maintained orally, possibly encoded in songs, stories, or mnemonic devices. When populations were disrupted, when sea levels and coastlines changed dramatically, when cultural continuity was broken, this knowledge could have been lost. Some researchers have speculated that oral traditions and myths from various cultures may preserve extremely ancient knowledge. The idea is that stories passed down through generations might encode real historical events or geographical knowledge from periods long before writing existed. For example, Aboriginal Australian oral traditions describing landscapes that are now submerged have been analysed alongside geological data. In some cases, these traditions appear to accurately describe coastal features that existed 7,000 to 10,000 years ago. The stories speak of times when the sea level was lower, when islands were connected to the mainland, and when now submerged areas were dry land. Remarkably, these details match what we know from geological reconstructions. If Aboriginal Australians maintained accurate oral traditions for 10,000 years or more, what other knowledge might have been preserved in human oral traditions before being lost? And crucially, what traditions were lost entirely when cultures were disrupted? Some controversial researchers, notably Graham Hancock, have argued that various myths and legends worldwide encode memories of a lost, highly advanced civilization that was destroyed by global catastrophes at the end of the Ice Age. While mainstream archaeology strongly rejects the idea of a single, globe-spanning advanced civilization, there may be a kernel of truth in the general concept that oral traditions do preserve memories of real, sophisticated societies that were lost to climate catastrophe and rising seas. Consider flood myths. Nearly every culture around the world has flood stories. The biblical Noah's Ark, the Epic of Gilgamesh, Hindu stories of Manu, Greek myths of Deucalion, Native American flood stories, and countless others. For a long time, these were dismissed as purely mythical, but we now know that at the end of the Ice Age, sea levels rose dramatically. Coastal populations worldwide would have experienced their lands being steadily inundated. Could some flood myths represent cultural memories of this real event? Not necessarily a single global flood, but rather the common human experience of watching ancestral coastlines disappear beneath the waves? If so, these myths might be among the last echoes of lost coastal societies. There's another dimension to consider: technological knowledge. We've discussed stone tools, and it's true that stone tool technology was sophisticated, but Ice Age peoples almost certainly had technologies using materials that don't preserve well. We know they worked wood, at least for spears, digging, sticks, and other tools. They likely used plant fibers for cordage, baskets, and possibly textiles. Some Upper Paleolithic sites have provided evidence of woven materials. They used animal products: bone, antler, sinew, hides, and probably made adhesives from plant resins or animal products. They likely created containers from bark, hides, or woven materials, and they almost certainly used many other organic technologies that have left no trace. In favourable coastal environments, with abundant resources, these technologies might have become highly sophisticated. Boats or rafts for fishing and travel, fish traps and nets, storage containers, and preservation techniques. Structures more elaborate than usually survive, and specialised tools for processing marine resources. When these societies were disrupted, when the environments they specialised in disappeared underwater, much of this technological knowledge could have been lost. The survivors, relocating to new environments, would have had to adapt to different resources, different challenges. Some technologies would have been maintained, but others, those specifically adapted to now vanished environments, would simply fade away. Social and organisational knowledge is another category worth considering. Complex societies require sophisticated social structures, systems for maintaining order, resolving disputes, organising collective action, and transmitting authority or leadership. Even without writing, societies can maintain complex social structures through oral tradition, ritual, and cultural practice. If large-scale societies existed in Ice Age coastal zones, as the monumental architecture at sites like Göbekli Tepe suggests is possible, they would have required sophisticated social organisation. Leadership structures, whether religious, political, or both, systems for coordinating labour, mechanisms for integrating diverse groups, cultural institutions for maintaining identity and cohesion. When these societies collapsed or were disrupted, when populations were scattered or reduced, these social structures would have disintegrated. The knowledge of how to organize large-scale societies, the traditions and practices that maintained them, could have been lost. Subsequent societies might have had to rebuild social complexity from scratch, reinventing solutions to problems that had already been solved. This brings us to an uncomfortable possibility that human cultural development has not been a steady, linear progression from simple to complex, but rather a more turbulent process with periods of advancement, disruption, loss, and rebuilding. That the end of the Ice Age might represent a major disruption, a near reset that erased significant achievements and required subsequent societies to rediscover or reinvent knowledge that had been lost. We can't prove this happened. The evidence is fragmentary, and much of it is now underwater or otherwise inaccessible, but the circumstantial case is compelling. We know that sophisticated hunter-gatherer societies existed in the late Ice Age. We know that coastal environments were likely the most favorable for human occupation. We know that these coastal areas were massively disrupted by climate change, the Younger Dryas, and sea level rise. And we know that significant knowledge can be maintained in oral societies but is vulnerable to disruption. The logical inference is that substantial knowledge systems were likely lost. How much? We can't say. How sophisticated? We don't know. But the absence of evidence, given that most of the evidence is literally underwater, shouldn't be taken as evidence of absence. To understand what might have been lost, we need to examine more closely the gaps and mysteries in the archaeological record. Archaeological mysteries and gaps in the record. The archaeological record of human history is not a complete book. It's more like a puzzle with most pieces missing, and the pieces we do have are scattered, fragmentary, and often difficult to interpret. When we add the factor that prime real estate for Ice Age human habitation is now underwater, the incompleteness becomes even more stark. Let's examine some specific mysteries and gaps that might point to lost sophistication. First, consider the distribution of early Neolithic sites. When agriculture emerged, it appeared in several regions relatively quickly. The Fertile Crescent, modern-day Iraq, Syria, Lebanon, Israel, Palestine, and parts of Turkey and Iran, northern China, sub-Saharan Africa, Mesoamerica, and the Andes. The traditional narrative suggested agriculture was invented independently in these regions, but the transitions happened within a few thousand years of each other, which, given the vast timescales of human history, is remarkably coincidental. Could there have been earlier precursors that influenced these developments? Could knowledge of plant cultivation, animal domestication, or social organization have spread from now lost societies? We can't prove it, but the pattern is intriguing. Consider also the megalithic traditions. Göbekli Tepe, as we've discussed, dates to around 9,500 BCE. But megalithic structures, large stone monuments, appear across widely dispersed regions over the following millennia. Temple complexes in Malta, stone circles in Britain and Ireland, including Stonehenge, megalithic structures in Korea and Japan, and various stone monuments in other parts of the world. Did these represent entirely independent inventions? Or did they stem from older, more widespread traditions of stoneworking and monument building? If sophisticated societies with knowledge of stone construction existed in coastal zones before these areas were flooded, could their traditions have influenced later inland societies? There's a pattern in the archaeological record that's often overlooked: the sudden appearance of sophisticated cultural elements with no clear precursors. This happens repeatedly. Complex art appears seemingly fully formed in the Upper Paleolithic. Advanced stone tool technologies appear suddenly in various regions. Sophisticated social organization, as evidenced by Göbekli Tepe and similar sites, appears without obvious earlier examples. The standard explanation is that we simply haven't found the precursors, that preservation is poor, that sites are rare, and that's certainly true. But it's also possible that some precursors are now underwater, that the most sophisticated early developments occurred in coastal zones that are no longer accessible. Let's focus on specific mysteries. One is the question of the first Americans. For decades, the Clovis culture, appearing around 13,000 years ago, was considered the first human presence in the Americas. But increasingly, evidence suggests earlier arrivals. Sites in South America, such as Monteverde in Chile, show human presence perhaps 18,000 years ago or earlier. Genetic evidence suggests humans may have been in the Americas 20,000 years ago or more. But here's the puzzle. If humans arrived earlier, where are they in the archaeological record? Why is there a gap between the earliest evidence and the widespread Clovis culture? One possibility is that early Americans lived primarily along coasts, following marine resources. These coastal sites would now be underwater, as sea levels have risen substantially since the Ice Age. The Clovis culture, appearing around the time of the Younger Dryas, might represent survivors moving inland after coastal areas were disrupted. This scenario suggests that a potentially sophisticated coastal adaptation, one that allowed humans to spread rapidly along ice-free coastlines, even during glacial maximums, might have been lost when sea levels rose. Another mystery involves the so-called Neolithic Revolution itself. For much of human history, people were mobile hunter-gatherers. Then, relatively rapidly, many societies transitioned to agriculture and settled life. The question of why this happened has puzzled researchers for decades. Traditional answers focused on environmental change. The end of the Ice Age created favorable conditions, population pressure, growing populations forced people to intensify food production, or cultural innovations. But what if the transition was also influenced by lost knowledge? Some researchers have speculated that proto-agricultural practices, collecting and managing wild plants, possibly even early cultivation, might have been practiced by Ice Age societies. These practices could have been disrupted by climate change and sea level rise, then rediscovered or reinvented in the early Holocene. Evidence from sites like Göbekli Tepe complicates the narrative. The site shows complex social organization and monumental building before the full adoption of agriculture. This suggests that social complexity didn't necessarily follow agriculture but could precede it. If hunter-gatherer societies could achieve this level of organization, what else might they have achieved in favorable coastal environments? There's also the mystery of genetic patterns. Modern genetic studies of human populations reveal complex patterns of ancient migrations, mixing, and population bottlenecks. Some of these patterns suggest population crashes, periods when human numbers dropped dramatically. One particularly interesting finding is evidence of a population bottleneck in many human populations around the time of the Younger Dryas. Genetic diversity patterns suggest population sizes may have dropped significantly during this period. This aligns with the idea that the Younger Dryas was catastrophic for human populations, not just ecologically disruptive, but actually reducing human numbers substantially. If populations crashed, cultural complexity would likely have been lost. Small, isolated groups, focused on immediate survival, would have little capacity to maintain elaborate knowledge systems, social institutions, or cultural traditions. The recovery, the rebuilding of population and cultural complexity might have required centuries or millennia. Another gap in the record involves maritime adaptations. We know humans reached Australia by at least 65,000 years ago, requiring sea voyages. We know people colonized islands in the Mediterranean during the Paleolithic. There's evidence of marine resource use from quite early in human prehistory, but we have remarkably little evidence of boats, navigation techniques, or seafaring traditions from the Ice Age. Why? Partially because boats made from organic materials don't preserve well, but also, potentially, because sophisticated maritime cultures lived along coastlines that are now underwater. The archaeological evidence of seafaring, harbours, boat-building sites would all be submerged and difficult to access. If substantial maritime societies existed during the Ice Age, utilising coastal and marine resources with developed knowledge of boat building, navigation, and marine ecology, virtually all physical evidence of these societies would now be underwater. We would see only indirect evidence. The fact that people reached remote islands, the presence of marine resources in some sites, genetic evidence of coastal migration routes. This raises a profound question. How much of human history is hidden underwater? And how does this invisible history change our understanding of human capabilities during the Ice Age? Some researchers have begun to investigate submerged sites. Efforts in the North Sea, off the coasts of Denmark, in the Mediterranean, and along the North American coasts have located submerged landforms and, in some cases, artifacts. But this work is expensive, technically challenging, and only scratches the surface. We've explored a tiny fraction of the submerged continental shelves. One striking example is Doggerland, the land that once connected Britain to continental Europe. This was a vast plain, rich in resources, that existed throughout much of the Ice Age. As sea levels rose, Doggerland gradually became an archipelago of islands, then finally disappeared beneath the North Sea around 6000 BCE. Archaeological evidence from Doggerland is scarce, limited to artifacts occasionally dredged up by fishing boats or found along modern coastlines. But seismic surveys have mapped the submerged landscape, revealing river valleys, lakes, hills, and coastlines. This was clearly a habitable, likely well-populated area. Where are the sites? They're buried beneath meters of marine sediment, accessible only through expensive and difficult underwater archaeology. If Doggerland, despite being one of the most studied submerged landscapes, remains largely mysterious, what about the thousands of other submerged coastlines worldwide? The Persian Gulf, once a river valley, now a body of water. The Sunda Shelf connecting Southeast Asian islands. The Sahul Shelf, extending from Australia. Beringia between Asia and Alaska. All of these were vast terrestrial areas during the Ice Age. All were flooded by rising seas, and all potentially hosted human populations. The archaeological record, in other words, is biased, heavily biased. We find sites that remain dry or that were in caves. We miss sites that are now underwater or deeply buried. And if the most favourable environments for human habitation were coastal, as modern analogues suggest, then we're missing precisely the areas where human achievement might have been greatest. This brings us to a methodological problem. How do we study something that's largely inaccessible? How do we reconstruct lost societies when the evidence is buried beneath the ocean? One approach is through oral traditions, examining myths and legends for possible kernels of historical truth. Another is through genetic studies, looking for patterns that suggest past population dynamics. A third is through environmental reconstruction, using geology and paleoclimatology to understand what environments were like and inferring where humans would have been. And increasingly, researchers are conducting underwater archaeology, literally diving to submerged sites and using remote sensing technologies to map underwater landscapes. But even with these approaches, our knowledge will remain fragmentary. We will likely never recover a complete picture of Ice Age coastal societies. But what we're learning suggests these societies were real, were substantial, and likely possess sophistication that has been underestimated. The gaps in the archaeological record aren't just gaps, they're missing chapters, potentially entire volumes of human history. And some of what's missing might fundamentally change how we understand human cultural development. One final mystery worth considering: the question of cultural continuity. In some regions, we can trace cultural traditions over long periods. Certain tool styles, artistic motifs, or practices persist for thousands of years. But in other cases, there are abrupt changes, sudden shifts in archaeological signatures that suggest population replacement, cultural disruption, or major reorganization. The end of the Ice Age and the Younger Dryas period show several such disruptions. The disappearance of the Clovis culture in North America, the transition from Paleolithic to Mesolithic cultures in Europe, the emergence of Neolithic societies in the Near East. Each of these transitions might represent normal cultural evolution, or they might represent disruptions, losses of previous traditions, replacements of earlier populations. Without complete evidence, we can't say definitively, but the pattern suggests that the end of the Ice Age was a period of tremendous upheaval, not just environmentally but culturally, and in such upheavals, knowledge is often lost. So the archaeological record, incomplete as it is, suggests several things: that Ice Age humans were more sophisticated than often assumed, that favourable coastal environments are now underwater and largely unexplored, that the end of the Ice Age coincided with major cultural disruptions, and that substantial knowledge systems might have been lost during this period. To understand how this loss might have occurred, we need to consider not just the physical evidence, but also the oral traditions that might preserve memories of these lost societies. The role of oral traditions and myths. For most of human history, knowledge was transmitted orally. There was no writing, no books, no external storage of information. Everything people knew had to be remembered and passed down through speech, song, story, and ritual. In some ways, this seems impossibly fragile. How could complex knowledge survive across generations without being corrupted, forgotten, or lost? But oral cultures have proven remarkably capable of preserving information. Aboriginal Australian cultures have maintained oral traditions for tens of thousands of years. Polynesian navigators preserved detailed knowledge of ocean routes, island locations, and navigation techniques through oral tradition. Ancient Indian texts like the Vedas were transmitted orally for centuries or millennia before being written down, with remarkable fidelity preserved through precise memorization techniques. The key is that oral societies develop specific methods for preserving important information. Knowledge is encoded in songs, which use rhythm and melody to aid memorization. Stories are told repeatedly, with crucial details reinforced through repetition and ritual. Specialized knowledge holders, elders, priests, or specialists are tasked with maintaining and transmitting specific information. And cultural practices, ceremonies, rituals, provide contexts for rehearsing and reinforcing important knowledge. Given these capabilities, it's entirely plausible that memories of significant events could be preserved for thousands of years in oral tradition. And when we examine myths and legends from around the world, particularly those involving catastrophic floods, ancient homelands, or lost golden ages, we find intriguing patterns. Let's start with flood myths. They're ubiquitous. The biblical flood story is well known, but similar stories appear in Mesopotamian literature. The Epic of Gilgamesh describes a great flood from which Utnapishtim survives. Hindu texts describe Manu being warned of a coming flood and building a boat. Greek mythology includes the story of Deucalion and Pyrrha surviving a flood sent by Zeus. Chinese mythology includes flood stories associated with the legendary Emperor Gun. Native American tribes across both continents have flood traditions. The list goes on. Nearly every culture has a story of a catastrophic flood that destroyed a previous world or previous people. For a long time, these were dismissed as purely mythological, perhaps inspired by local flood events or serving symbolic functions in cultural narratives. But we now know that something very like a global flood did occur, the post-glacial sea level rise that inundated coastlines worldwide. Between 15,000 and 7,000 years ago, sea levels rose by approximately 120 meters. This wasn't a sudden flood in most places, but a relentless, generation-by-generation rise that gradually drowned coastal plains, river valleys, and estuaries. For populations living along these coasts, it would have been catastrophic. Not necessarily in terms of immediate death, people could relocate inland, but in terms of cultural disruption. Ancestral territories would be lost, sacred sites submerged, landmarks gone, hunting and fishing grounds underwater. Over the generations, communities would have watched their world literally disappear beneath the waves. Is it possible that flood myths represent cultural memories of this real event, not as a single, sudden deluge, but as the common human experience of watching coastlines inexorably advance inland swallowing the lands where ancestors had lived for thousands of years? Some researchers have begun systematically examining this possibility. In 2020, a study examined Aboriginal Australian oral traditions describing landscapes and geological features. These traditions spoke of times when the sea level was lower, when islands were connected to the mainland, and when specific coastal features existed that are now submerged. The researchers compared these traditional stories with geological reconstructions of past coastlines. In several cases, the traditional descriptions matched geological reality from 7,000 to 10,000 years ago. The stories appeared to preserve accurate geographical knowledge from a time when those coastlines still existed. If Aboriginal Australians maintained accurate oral traditions for 10,000 years, what other knowledge might human cultures have preserved? And crucially, what knowledge was lost when cultures were disrupted or destroyed? Consider the traditions of lost homelands. Many cultures have stories of ancient lands that once existed but are now gone. Atlantis is the most famous, described by Plato as an advanced civilization that sank beneath the waves. While most scholars consider Atlantis purely fictional or symbolic, the concept, a lost land, swallowed by the sea, resonates across cultures. In Hindu mythology, there are references to Kumari Kandam, a lost continent said to have existed south of India. Welsh legends speak of Cantre'r Gwaelod, a lowland kingdom allegedly drowned by the sea. Breton folklore includes stories of the city of Yez, submerged beneath the waves. Japanese legends mention sunken lands. Could these stories preserve fragmented memories of real lands that were lost to rising seas? Not advanced technological civilizations in the modern sense, but substantial human settlements, possibly sophisticated by Neolithic standards, that were inundated as coastlines changed. Let's consider specific cases. The Persian Gulf is a large body of water today, but during the Ice Age, when sea levels were lower, it was a river valley, a likely fertile and well-watered region. As sea levels rose, this valley gradually filled, becoming the Gulf we know today. The flooding would have occurred over several thousand years, from roughly 15,000 to 8,000 years ago. If human populations lived in this river valley, as seems very likely given its favourable conditions, they would have experienced generations of gradual inundation. Could memories of this event be preserved in the flood myths of Mesopotamian cultures? The Epic of Gilgamesh, one of the oldest written texts, describes a catastrophic flood. Might this represent a cultural memory of the Persian Gulf's inundation, transmitted orally for thousands of years before being written down? Similarly, the Black Sea was once a lower freshwater lake. Around 7,000 years ago, according to one hypothesis, the Mediterranean broke through the Bosphorus Strait, causing a massive flood that filled the Black Sea to its current level. If true, this would have been a dramatic, rapid flooding event that would have devastated any coastal settlements. Could this event be remembered in flood traditions from the region? Another intriguing case involves the Doggerland region we discussed earlier. As Doggerland gradually became an archipelago and then disappeared, people living there would have experienced the loss of their homeland over multiple generations. Recent studies suggest some traditions in Northern Europe, particularly those involving submerged lands or lost territories, might preserve memories of Doggerland. But flood myths are just one category. There are also myths of golden ages or earlier advanced peoples. Many cultures have traditions suggesting that ancestors possessed great knowledge or abilities that have been lost. In Greek mythology, there's the idea of ages, gold, silver, bronze, iron, with the golden age representing a better time. Hindu cosmology includes the concept of yugas, cosmic cycles, with earlier ages being superior. Some Native American traditions speak of earlier peoples who were destroyed. Mesoamerican cultures had traditions of previous worlds that were destroyed in catastrophes. Again, these could be purely mythological, serving cultural functions of explaining the world or establishing moral frameworks. But they could also preserve memories of real societies that existed before catastrophic changes. One controversial researcher who has explored these ideas extensively is Graham Hancock. In books like Fingerprints of the Gods and Magicians of the Gods, Hancock has argued that various myths and anomalies point to the existence of an advanced Ice Age civilization that was destroyed by global catastrophes around 12,000 years ago. Mainstream archaeology has strongly rejected Hancock's ideas, arguing that there's no physical evidence for such a civilization and that his interpretations of myths are speculative. And it's true that Hancock's proposals of a globally unified advanced civilization are not supported by evidence. However, there may be truth in a more modest version of the idea that sophisticated, regional societies did exist during the Ice Age, that some of these societies lived in now submerged coastal zones, that these societies possessed substantial cultural and technological achievements, and that they were disrupted or destroyed by the climate changes and sea level rise at the end of the Ice Age. This doesn't require belief in a single, globe-spanning, lost civilization. It simply requires recognizing that human societies during the Ice Age were more sophisticated than often assumed, that the most favorable environments for these societies are now underwater, and that oral traditions might preserve fragmented memories of these lost cultures. Let's consider what might realistically have been lost. Not advanced metallurgy or writing or cities in the conventional sense, but perhaps societies with sophisticated knowledge of astronomy, used for timekeeping and navigation, detailed understanding of their environments, including marine and plant resources, monumental architecture in stone, as evidenced by Göbekli Tepe, complex social structures capable of organizing large-scale collective actions, artistic and symbolic traditions representing developed belief systems, and potentially early forms of plant cultivation or animal management. Such societies, if they existed in favorable coastal zones, would have been highly vulnerable to sea level rise. Their territories would have been progressively inundated, their populations would have been displaced, their cultural continuity would have been disrupted, and much of their knowledge would have been lost. Oral traditions, in this scenario, would preserve fragmented memories, not detailed accounts. Oral transmission without writing is imperfect over many millennia, but general impressions that ancestors lived in different places now underwater, that a time of catastrophe, flooding, climate change, disrupted the world, that earlier peoples possessed knowledge or abilities that were lost, and that the world was once different, perhaps better in some ways. This aligns remarkably well with the pattern we see in myths worldwide. Not perfectly. Myths are also shaped by cultural needs, symbolic functions, and imaginative elaboration. But the core elements, ancestral lands, catastrophic flooding, lost knowledge, fit the scenario of sophisticated Ice Age coastal societies disrupted by the end of the Ice Age. So while we should be cautious about taking myths too literally, we shouldn't dismiss them entirely. They may contain real historical kernels, memories of actual events and real societies, preserved imperfectly but genuinely across thousands of years. The question then becomes, what do these traditions, combined with archaeological evidence and geological knowledge, tell us about what might have been lost? To answer that, we need to look more closely at the specific environmental catastrophes that accompanied the end of the Ice Age. Environmental catastrophes and rapid change. The end of the Ice Age was not a gentle transition. It was a period of extreme environmental instability, marked by rapid climate shifts, catastrophic flooding events, sea level rise of unprecedented scale, and potentially cosmic impacts. Understanding these changes is crucial to understanding what human societies faced and what they might have lost. Let's start with the scale of sea level rise. At the last glacial maximum, around 20,000 years ago, sea levels stood approximately 120 meters lower than today. To put this in perspective, that's the height of a 40-story building. Vast areas of continental shelf, now underwater, were dry land. These areas weren't marginal environments. Continental shelves are typically shallow, gently sloping regions. During the Ice Age, they would have featured river valleys, lakes, estuaries, coastal plains, and varied ecosystems ranging from forests to grasslands. These areas would have been highly favorable for human habitation. Abundant fresh water from rivers, marine and estuarine resources, fish, shellfish, seabirds, terrestrial game animals, plant resources, and moderate climates. Coastal areas typically have less extreme temperatures than inland regions. Global estimates suggest that the exposed continental shelves during the Ice Age represented an additional 19 million square kilometers of land, an area equivalent to about twice the size of the United States. This wasn't scattered, insignificant territory. It was prime real estate for hunter-gatherer populations. As temperatures rose and ice sheets melted, this land gradually disappeared. The rise wasn't constant. It occurred in pulses, periods of rapid rise interspersed with slower periods. The most dramatic rises occurred during meltwater pulses, events when large volumes of meltwater were released from collapsing ice sheets, causing global sea levels to jump by several meters within decades or centuries. One such event, Meltwater Pulse 1A, occurred around 14,600 years ago. In this event, sea levels rose by approximately 16 to 25 meters in less than 500 years, possibly as little as 200 to 300 years. For coastal populations, this would have been catastrophic. A rise of 20 meters means that low-lying coastal areas, precisely where settlements would be located, would be progressively inundated over just a few generations. Imagine living in a coastal community and knowing, because your elders remembered, that the sea has advanced several kilometers inland just since your grandparents' youth, that ancestral fishing grounds are now underwater, that sacred sites are submerged, that you will, in your lifetime, need to relocate farther inland. And you know this pattern will continue for your children and their children. This isn't mythological. This is the real experience coastal populations would have faced. And it would have been devastating, not just physically, losing territory, but also culturally, losing landmarks, sites of significance, and connections to ancestral lands. The situation was even more dramatic in some regions. The flooding of the Persian Gulf, the transformation of Doggerland from plains to archipelago to open sea, the inundation of the Sunda Shelf in Southeast Asia, and the submergence of coastal areas around every continent all occurred during this period. But sea level rise wasn't the only environmental challenge. Climate itself was unstable. The general trend was warming, but superimposed on this trend were rapid fluctuations. The most dramatic was the Younger Dryas, which we've discussed. But even outside this event, the climate was variable on timescales of decades to centuries. Temperature shifts of several degrees could occur within decades. Precipitation patterns shifted, transforming regions from relatively wet to arid or vice versa. Vegetation zones migrated rapidly, forests expanding in some areas, retreating in others, tundra replacing forests in the north during the Younger Dryas, then forests returning when warming resumed. For human populations dependent on specific resources, these changes could be existential. A population adapted to hunting tundra game would face starvation if their environment transformed to forest. A group dependent on specific plant resources would need to relocate if those plants' ranges shifted. And coastal populations dependent on marine resources would face the double challenge of habitat change and sea level rise. Then there are the acute catastrophes. The Storegga slide, which occurred around 6,100 BCE, was a massive underwater landslide off the coast of Norway. It triggered a tsunami that struck coastal areas around the North Sea, including Scotland, Norway, and likely Doggerland. Evidence suggests waves reached heights of up to 25 meters in some areas, traveling inland for miles, devastating coastal settlements. While the Storegga tsunami occurred relatively late in the post-glacial transition, it illustrates the kinds of acute catastrophes coastal populations faced. Similar underwater landslides and tsunamis probably occurred elsewhere as ice sheets collapsed and sea levels rose, destabilizing underwater slopes. The Younger Dryas impact hypothesis, if correct, would represent an even more catastrophic event. An impact or airburst large enough to trigger global climate change would have caused immediate, widespread devastation. Continental-scale wildfires, impact winter conditions, tsunamis if the impact occurred over water, and disruption of ecosystems worldwide. Even if the impact hypothesis is incorrect, the Younger Dryas itself was catastrophic. A rapid return to near-glacial conditions after millennia of warming would have devastated populations adapted to warmer climates. Agricultural experiments, if any were underway, would have failed. Food sources would have become scarce. Population sizes likely dropped. Genetic evidence supports this. Studies of human genetic diversity show signatures of population bottlenecks, periods when population sizes dropped dramatically around the time of the Younger Dryas. This suggests that human populations worldwide were stressed, reduced in numbers, and possibly isolated in refugia, small areas where conditions remain tolerable. When populations crash, culture suffers. Small groups focused on immediate survival have limited capacity for maintaining elaborate traditions, transmitting complex knowledge, or supporting specialists. Knowledge holders, elders with specialized understanding, become critically important. If they die before passing on their knowledge, it's lost forever. In a catastrophe, mortality among older people is often high. They may be less mobile, less able to adapt to harsh conditions, and in oral cultures, they're also the primary repositories of knowledge. Losing elders means losing knowledge in a way that literate cultures don't experience as acutely. So the environmental catastrophes at the end of the Ice Age, the sea level rise, climate instability, the Younger Dryas, acute disasters like tsunamis, and potentially a cosmic impact would have hit human populations hard, particularly coastal populations who faced the loss of their homelands to rising seas. The survivors would have been scattered, reduced in numbers, and focused on immediate survival. Much cultural complexity would have been lost. Knowledge systems would have fragmented. Traditions would have been forgotten, and when populations eventually recovered, they would have had to rebuild, often without the accumulated wisdom of previous generations. This scenario, supported by geological, archaeological, and genetic evidence, suggests that substantial knowledge and cultural achievement were likely lost at the end of the Ice Age, not because there was an advanced technological civilization in the modern sense, but because sophisticated hunter-gatherer societies adapted to favorable coastal environments were disrupted and scattered by environmental catastrophe. So what specifically might have been lost? Let's consider the possibilities. What could have been lost? Reconstructing the invisible. When we ask what might have been lost at the end of the Ice Age, we're engaging in informed speculation. We can't know for certain what sophisticated Ice Age coastal societies possessed because the direct evidence is underwater and largely inaccessible. But we can make educated guesses based on what we know was possible, what ethnographic parallels suggest, and what circumstantial evidence hints at. Let's start with astronomical knowledge. Many traditional societies possess surprisingly sophisticated astronomical understanding. Aboriginal Australians recognized stellar patterns, tracked celestial events, and integrated astronomical observations into their cosmology. Polynesian navigators used stars for long-distance navigation. Ancient Mesopotamian and later societies developed detailed astronomical records. There's no reason Ice Age peoples couldn't have achieved similar sophistication. In fact, some evidence suggests they did. Certain cave paintings appear to represent stellar configurations. Bone artifacts with regular markings have been interpreted as lunar calendars, and the astronomical alignments of some later Neolithic structures suggest knowledge that likely predates those structures. For coastal societies, astronomical knowledge would have been particularly valuable. Stars provide navigation for maritime travel. The moon's phases correlate with tides, crucial for coastal living. Seasonal star patterns could indicate optimal times for fishing, hunting, or gathering, and celestial events, solstices, equinoxes, could anchor calendars for tracking seasonal cycles. If Ice Age coastal societies developed sophisticated astronomical traditions over thousands of years of observation, this knowledge would have been encoded orally, possibly in myths, songs, or mnemonic devices. The loss of these societies would mean the loss of this accumulated knowledge. Similarly, ecological knowledge would have been extensive. Hunter-gatherer societies typically possess encyclopedic knowledge of their environments. They can identify hundreds or thousands of plant species, understanding which are edible, which are medicinal, how to process toxic plants to make them safe, and when and where different species are available. For coastal societies, this knowledge would extend to marine and estuarine ecosystems, understanding fish behavior and migration patterns, recognizing optimal locations and times for shellfish gathering, knowledge of seabird nesting patterns, understanding of tides and their effects on resource availability, and sophisticated understanding of the interconnections between terrestrial, freshwater, and marine ecosystems. This knowledge represents thousands of years of accumulated observation, experimentation, and refinement. It's not written in books, but encoded in cultural practices, stories, and expert knowledge passed from generation to generation. When coastlines shift dramatically, when ecosystems are disrupted, when populations are scattered, this highly specific, place-based knowledge becomes partially or entirely obsolete. New environments require new learning. If the transition is too rapid, if elder knowledge holders die, if cultural continuity is broken, the depth of traditional ecological knowledge can be lost. Consider medicinal knowledge specifically. Many traditional societies possess sophisticated pharmacopoeias. They know which plants treat infections, reduce inflammation, relieve pain, aid digestion, or address various ailments. This knowledge represents generations of careful observation, experimentation, sometimes fatal, and transmission of successful remedies. If Ice Age societies, particularly those in diverse coastal environments with access to numerous plant species, developed extensive medicinal knowledge, this would have been entirely oral and experiential, no written records. If the societies were disrupted, if the plants they used were found in now submerged coastal zones, if the specialists who held this knowledge died, the information would simply vanish. We know modern pharmaceutical research has discovered numerous active compounds in plants used by traditional societies. What compounds might we have never discovered because the knowledge was lost when Ice Age societies collapsed? Technological knowledge is another category. We've discussed stone tools, but Ice Age peoples almost certainly possessed sophisticated technologies using perishable materials. Woodworking techniques for creating spears, tools, possibly boats or rafts, fiber technologies for creating cordage, nets, possibly baskets or textiles, hide working for creating clothing, containers or shelters, knowledge of adhesives made from plant resins or animal products, possibly preservation techniques for storing food, drying, smoking, fermentation. In favorable environments with abundant resources, these technologies might have become highly sophisticated. Specialized tools for specific tasks, complex processing techniques, innovations specific to coastal resources. Most of this technology would leave little archaeological trace. Wood, fiber, hide, they decompose except under exceptional circumstances. We would be left with stone tools and occasionally bone tools, giving us an incomplete and misleading picture of technological sophistication. When coastal societies were disrupted, when populations relocated to different environments, much technology specific to coastal adaptations would have been abandoned. The survivors would have adapted to new resources, new environments, new challenges. Some general technologies would transfer, but specialized coastal knowledge would be lost. Social and organizational knowledge represents another dimension. Complex societies require sophisticated social structures, mechanisms for maintaining order and resolving disputes, systems for organizing collective action, whether for construction projects, ceremonial events, or community defense, leadership structures and means of selecting or legitimizing leaders, cultural institutions for maintaining group identity, rituals, initiations, shared stories. The evidence from Göbekli Tepe and similar sites suggests some hunter-gatherer societies achieved remarkable organizational sophistication. Building structures with multi-ton stones required coordinating hundreds of people, planning, managing labor, and maintaining social cohesion. If such organizational capacity existed among Ice Age coastal societies, as seems plausible given favorable environmental conditions and potentially high population densities, this represents substantial social complexity. Not necessarily hierarchies in the sense of later state societies, but complex egalitarian or semi-egalitarian structures that could coordinate large-scale collective action. When societies collapse or are disrupted, social structures disintegrate. The knowledge of how things were organized, the traditions that maintained social cohesion, the institutional memory, is lost. Subsequent societies have to rebuild, often from scratch, reinventing solutions to organizational problems that had already been solved. There's one more category worth considering: symbolic and cosmological knowledge. All human societies have systems of meaning, ways of understanding the world, humanity's place in it, and the nature of existence. These systems are encoded in myths, rituals, art, and cultural practices. Ice Age societies, based on their art, clearly possessed rich symbolic lives. The cave paintings, carved figurines, personal adornments, and ritual behaviors evident in the archaeological record show sophisticated symbolic thinking and abstract conceptualization. For coastal societies with their own specific adaptations, cosmological systems would have been shaped by their environments. Myths explaining the sea, tides, marine creatures, rituals connected to fishing, navigation, or seasonal patterns, art representing coastal and marine life. When these societies were disrupted, their specific symbolic systems would have been disrupted as well. Some elements might persist in modified form among survivors, but much would be lost. The complexity, the specific details, the deep meanings would fade across generations of dislocation. So what might have been lost? In sum, not a technological civilization in the modern sense, not writing, metallurgy, or cities, but potentially extensive astronomical knowledge accumulated over millennia of observation, detailed ecological understanding, particularly of coastal and marine environments, sophisticated medicinal knowledge from resource-rich, diverse environments, specialized technologies for coastal living, now irrelevant in inland contexts, social and organizational systems capable of large-scale coordination and rich symbolic and cosmological traditions specific to coastal adaptations. Is this speculation? Yes, but it's informed speculation based on what we know about hunter-gatherer societies, what we know about the environments, and what we know about the sophistication that's possible without agriculture or writing. The tragedy is that we can't verify this. The direct evidence is underwater, buried beneath marine sediments, effectively locked away. We have to infer, deduce, and imagine, guided by the fragments we have found and the logic of what must have been. But in recent years, technology and dedicated research have begun to pull back the veil on some of these lost worlds. Let's look at what modern discoveries are revealing. Modern discoveries and rewriting history. In the past few decades, archaeology has undergone something of a revolution in how we understand the capacities of pre-agricultural societies. Discovery after discovery has challenged old assumptions, revealing sophistication where it wasn't expected. And nowhere is this more evident than in our understanding of the late Ice Age and the early Holocene period. Göbekli Tepe, which we've discussed, is perhaps the most famous example. When Klaus Schmidt began excavating the site in the 1990 seconds, he quickly realized its significance. Here were massive stone structures, requiring sophisticated organization, planning, and construction, dated to 9,500 BCE or earlier, before agriculture, before pottery, before what we thought was civilization. The site forced a reconsideration of the entire narrative of human development. The old model was simple. First, agriculture provided surplus food, then surplus enabled social complexity. Social complexity led to hierarchy and specialization, And finally, monuments could be built. Göbekli Tepe reversed this. Monumental architecture came first, suggesting complex social organization preceded agriculture rather than following it. Since Göbekli Tepe, numerous other pre-pottery Neolithic sites have been discovered or re-examined in the same region of southeastern Turkey. Karahan Tepe, Navali Chori, Hamzan Tepe, and others show similar patterns: monumental structures, T-shaped pillars, sophisticated carving. This was clearly a widespread cultural phenomenon, not a one-off anomaly. But southeastern Turkey is just one region. Similar discoveries are being made elsewhere. In Peru, the Caral super civilization, dating to approximately 3000 BCE, shows sophisticated urbanism, monumental architecture, and complex society without ceramic pottery and with minimal evidence of warfare. This challenges assumptions about what's necessary for complex society. In China, sophisticated rice cultivation appears remarkably early, possibly 10,000 years ago or more. In the Levant, evidence of proto-agricultural practices, intensive plant collection and processing dates back to the late Paleolithic. In the Americas, increasingly early dates for human presence, along with sophisticated adaptations, are pushing back timelines and complicating narratives. What unites these discoveries is a growing recognition. Late Paleolithic and early Neolithic peoples were far more capable than previously thought. They weren't passively waiting for the conditions that would allow civilization. They were actively creating complex societies, experimenting with new technologies and social forms, and achieving remarkable things. But what about the underwater sites? Can we actually investigate submerged landscapes and settlements? The answer is increasingly yes. Technology has advanced dramatically. Multibeam sonar can map underwater topography in detail. Sub-bottom profilers can reveal sediment layers and buried features. Remotely operated vehicles, ROVs, and autonomous underwater vehicles, AUVs, can explore deep sites. And underwater archaeology, while expensive and technically challenging, is becoming more feasible. The Doggerland project, led by Vince Gaffney at the University of Bradford, represents one of the most ambitious efforts, using seismic data originally collected by oil and gas companies. Gaffney's team has created detailed maps of the submerged landscape. They've identified river valleys, lakes, hills, and coastlines, creating a three-dimensional reconstruction of what Doggerland looked like before it was flooded. The landscape was extensive and varied. River valleys with fertile floodplains, upland areas providing game, coastal zones with marine resources. This was clearly prime real estate for hunter-gatherer populations. Where are the settlements? They're buried, typically under several meters of marine sediment. Finding them requires systematic survey, careful analysis, and often luck. Some artifacts have been recovered. Fishing boats occasionally dredge up stone tools, worked bone, and even fragments of human remains from the North Sea floor. A remarkable find in 2010 was a worked bone spear point, dated to approximately 10,000 BCE, that had been dredged up by fishermen. Analysis showed it had been used, possibly for fishing, providing direct evidence of human activity in now submerged Doggerland. More recently, targeted underwater surveys have located submerged settlements. In the Baltic Sea, off the coast of Denmark, researchers have found settlements dated to approximately 6,500 BCE, preserved underwater. These sites contain animal bones, stone tools, wooden artifacts, and evidence of structures. One site, Timmendorf Nordmole, has provided remarkable preservation of organic materials that normally decay. Similar work is underway off other coasts. Mediterranean sites, North American continental shelf, the Sunda Shelf in Southeast Asia. Each project reveals that submerged landscapes contain real archaeological sites, confirming that coastal populations existed in now underwater areas. The scale of what's potentially undiscovered is staggering. Globally, the continental shelves represent millions of square kilometers that were dry land during the Ice Age. Only a tiny fraction has been systematically surveyed. The vast majority remains unexplored, its archaeological secrets locked beneath marine sediments. Technological advances promise more. Satellite-derived bathymetry can help identify promising areas. Machine learning algorithms can analyze seismic data to flag potential archaeological features. And as underwater archaeology becomes more routine for offshore development projects, wind farms, oil platforms, more sites are being discovered almost accidentally. But there's also urgency. Some submerged sites are being destroyed. Bottom trawling by fishing vessels damages underwater sites. Offshore development, wind farms, oil drilling can disturb or destroy archaeological features. And even without human activity, natural processes, erosion, sediment movement gradually degrade sites over time. Researchers are racing to document what they can before it's lost, but resources are limited. Underwater archaeology is expensive, funding is scarce, and the scale of the task is enormous. Despite these challenges, what's being discovered is transforming our understanding. We now know that substantial populations lived in now submerged areas, that these populations left behind settlements, tools, and evidence of complex behaviors, and that the flooding of these areas represented a major disruption to human populations. The implications extend beyond just adding sites to the archaeological map. These discoveries force us to reconsider the entire narrative of human development. If prime real estate was coastal, and coastal areas are now underwater, then our picture of Ice Age and early Holocene humanity is fundamentally incomplete. We've been studying the margins, the inland areas, the caves, while missing the core, the coastal zones where populations were likely densest and sophistication potentially greatest. This isn't to say there were lost civilizations in the sense of Atlantis myths, but it does mean there were substantial, sophisticated societies that we've been missing from our reconstructions. Societies that possessed knowledge we haven't fully appreciated. Societies whose disruption and loss at the end of the Ice Age represents a real tragedy, not just for them, but for human knowledge as a whole. Modern discoveries are slowly revealing what was lost, but they're also revealing how much we still don't know. Each submerged site found raises more questions than it answers. Each artifact recovered hints at a larger context that remains invisible. The revolution in our understanding is ongoing, and as it continues, one question becomes increasingly important. How do we define advanced in the context of Stone Age societies? The nature of advanced in the Stone Age context. When we use the word advanced, we typically mean something specific, technological sophistication in a modern sense, metalworking, writing, architecture, machinery. By this definition, Ice Age hunter-gatherers were not advanced. They lacked these technologies. But is this the right definition? Is sophistication only measured by material technology, or could societies be advanced in other ways? In knowledge, social organization, cultural complexity, and adaptation to their environments. Let's reconsider what advancement means. In evolutionary terms, advanced is meaningless. Species aren't on a ladder leading somewhere. They're adapted to their specific environments and ecological niches. A microbe is not less advanced than a human. It's differently adapted. Similarly, cultures aren't on a single developmental track. Agricultural civilizations aren't inherently superior to hunter-gatherer societies. They're different adaptations to different circumstances. Each has advantages and disadvantages. Hunter-gatherer societies, traditionally viewed as primitive, actually possess remarkable sophistication in many domains. Ecological knowledge rivaling that of modern ecologists. Social structures that maintain order without formal hierarchies or coercion. Egalitarian systems that prevent accumulation of power or wealth. High levels of individual skill and competence. Most adults possess wide-ranging practical knowledge. In some ways, hunter-gatherer societies are more sophisticated than agricultural civilizations. Their knowledge of environments is typically deeper. Their social relations are often more egalitarian. Their individual members are more broadly skilled. They lack writing, complex architecture, and cities, but they excel in domains we value less in modern contexts. When we consider Ice Age societies, particularly those in favourable coastal environments, we should ask, advanced in what ways? Not in metal technology, obviously, not in writing or complex political structures, but potentially advanced in astronomical observation accumulated over thousands of years. Environmental knowledge, particularly of marine and coastal ecosystems, maritime technologies for navigation and fishing, social organizational capacity, evidenced by sites like Göbekli Tepe, cultural and artistic traditions, as seen in cave art and carved figurines. These forms of advancement are less visible archaeologically. They don't leave monumental ruins. They're often encoded in perishable materials or oral traditions, but they represent real sophistication, real accumulated knowledge, real cultural achievement. Consider a specific example: navigation. Polynesian navigators could travel thousands of miles across open ocean without instruments, using only stars, wave patterns, bird behavior, and traditional knowledge. This required extraordinarily sophisticated knowledge, detailed mental maps of vast ocean regions, understanding of currents, winds, and weather patterns, ability to integrate multiple environmental cues, and traditions for training navigators and transmitting knowledge. Is this advanced? By materialistic standards, no. The Polynesians didn't have compasses, sextants, or GPS, but by knowledge standards, absolutely. Their navigational abilities were astounding and represented accumulated wisdom passed down across generations. If Ice Age coastal societies possessed similar maritime traditions, developed over thousands of years of coastal and marine living, this would represent a sophisticated knowledge system. The loss of these societies would mean the loss of this knowledge, even if it never left a clear archaeological signature. Or consider another example: social organization. Many hunter-gatherer societies maintain remarkable social cohesion and order, without formal hierarchies, police, or laws. They achieve this through cultural norms, social pressure, consensus decision-making, and conflict resolution practices embedded in tradition. This is sophisticated social technology. It doesn't look like governments or bureaucracies, but it's effective at maintaining functioning societies. If Ice Age populations achieve similar or more complex forms of social organization, perhaps enabling larger group sizes or greater collective action than typical of modern hunter-gatherers, this would represent social advancement, even if it left little archaeological trace. The point is that advancement can take many forms. A society can be technologically simple by modern standards, but cognitively, socially, or ecologically sophisticated. And conversely, a society can be technologically advanced, but ecologically destructive or socially dysfunctional. When we ask whether advanced Stone Age cultures were lost at the end of the Ice Age, we need to be clear about what we mean by advanced. If we mean civilizations with writing, metallurgy, and cities, then no, there's no evidence for that. But if we mean societies with sophisticated knowledge systems, complex social organization, remarkable adaptation to their environments, and cultural traditions representing accumulated wisdom, then yes, such societies likely existed and likely were disrupted or lost. The tragedy isn't that we lost ancient cities or written libraries. It's that we lost accumulated knowledge that had taken thousands of years to develop. Astronomical observations passed down across hundreds of generations. Ecological understanding refined through millennia of living in specific environments. Social systems that worked, that maintained functioning communities without coercion. Cultural traditions that gave meaning, purpose, and identity to people's lives. When catastrophe struck, when coastlines flooded, when climate became chaotic, when populations crashed, much of this was lost. Not the people themselves, some survived, but the continuity, the depth, the accumulated wisdom. The survivors had to start over in new environments, often diminished in numbers and disconnected from their traditions. This is a different kind of loss than the destruction of cities or the burning of libraries, but it's no less real. It's the loss of knowledge that was never written down, of traditions that were never recorded, of wisdom that existed only in human memory and practice. And the question haunting this entire investigation is, how much poorer is humanity for this loss? What might we know if that knowledge had survived? What problems might already have solutions if traditional knowledge systems had persisted? What understanding of the natural world might we possess if thousands of years of careful observation hadn't been interrupted? We can't answer these questions definitively. The knowledge is gone, but we can honor the possibility that something valuable was lost, that our ancestors achieved more than we've recognized, and that the end of the Ice Age represents not just a geological transition, but a cultural catastrophe whose effects we're still experiencing. Conclusion: living with uncertainty and wonder. As we come to the end of this exploration, we find ourselves not with answers, but with questions. Not with certainty, but with possibilities. And perhaps that's appropriate. The past, especially the deep past, is not a closed book with all pages preserved. It's a fragmentary text with most pages missing, and we're left to infer what the missing sections might have said. What can we say with confidence? That late Ice Age hunter-gatherer societies were more sophisticated than long assumed. That sites like Göbekli Tepe demonstrate organizational and architectural capabilities that challenge our narratives. That favorable coastal environments, now submerged, likely hosted substantial human populations. That the end of the Ice Age brought catastrophic environmental changes, sea level rise of 120 meters, climate instability, the Younger Dryas event, and potentially cosmic impacts. That human populations were disrupted, reduced, and scattered during this period, and that knowledge systems maintained in oral traditions are vulnerable to disruption. What can we infer? Less certainly, but plausibly, that coastal societies likely achieved high levels of sophistication in various domains. That substantial knowledge, ecological, astronomical, social, technological, was probably lost when these societies were disrupted. That oral traditions and myths might preserve fragmentary memories of these lost societies, and that the archaeological record, biased toward inland and cave sites, misses much of late Ice Age human achievement. What remains speculation, interesting but unproven? That specific advanced knowledge systems, detailed astronomy, extensive pharmacopoeias, sophisticated maritime traditions existed and were lost. That oral traditions reliably preserve specific historical details from 10,000 or more years ago, and that any kind of unified or globe-spanning advanced culture existed, this seems highly unlikely, but regional sophistication is plausible. The honest answer to our title question, what if the Ice Age wiped out advanced Stone Age cultures, is, we don't know, but it's quite possible. Not advanced in the sense of having writing, metallurgy, or cities, but advanced in accumulated knowledge, social complexity, and cultural sophistication. The loss wouldn't have been instantaneous. It would have unfolded over centuries or millennia as coastlines shifted, climates changed, and populations adapted or declined. Some knowledge would have survived, passed down by refugees, integrated into new cultural contexts, but much would have been lost, especially knowledge specific to environments that no longer existed. This narrative challenges our assumptions about human progress. We like to think of history as a story of steady advancement, from simple to complex, from primitive to civilized. But what if the story is more complicated? What if there have been false starts, achievements followed by losses, sophistication that emerged only to be destroyed? The end of the Ice Age might represent such a rupture, not a complete reset. Humans survived and eventually thrived, but a significant disruption that erased accumulated knowledge and forced subsequent societies to rebuild, often without the benefit of earlier wisdom. If true, this has implications for how we view indigenous knowledge systems. Traditional ecological knowledge, maintained by cultures that avoided or resisted agricultural civilization, might represent fragments of very ancient wisdom, not primitive holdovers, but genuinely sophisticated understanding that has persisted despite disruptions. It also suggests humility in our assumptions about the past. We don't know what we don't know. The archaeological record is incomplete, fundamentally and irrevocably incomplete, because prime evidence is underwater. We should be cautious about declaring what was or wasn't possible for ancient peoples, and perhaps most importantly, this investigation reminds us that knowledge is fragile. It can be lost. Not just books in fires, though that too, but entire knowledge systems can vanish when the people who hold them are disrupted. In an age of global environmental change, this feels particularly relevant. What do we do with this uncertainty? First, we support research, underwater archaeology, careful excavation of late Ice Age sites, preservation of oral traditions, and integration of indigenous knowledge into academic frameworks all help fill in the gaps. Second, we remain open-minded but critical. We should be willing to revise our assumptions based on new evidence, but we should also demand good evidence before accepting extraordinary claims. Third, we honor the possibility that our ancestors achieved more than we know, that they possessed wisdom we've lost, that they deserve respect not as primitive precursors, but as fully human, fully capable people who faced tremendous challenges and sometimes created something remarkable. As you drift towards sleep tonight, let your mind wander back to those distant shores. Imagine coastlines that no longer exist, where people watched sunsets over landscapes now hundreds of meters underwater. People who knew the stars, who understood their environments with an intimacy we've lost, who created art and monuments and traditions. People whose stories are no longer told, whose names are forgotten, whose very existence is disputed. They were real. They lived, loved, struggled, and wondered. And when the seas rose, when their world transformed, some part of humanity's accumulated wisdom was lost with them. We can't recover what's gone, but we can remember that it existed. That loss is part of the human story, and that every gain often comes with some cost we don't recognize until later. The Ice Age is over. The world has moved on, but beneath the waves, buried in sediment, preserved imperfectly in myths and traditions, fragments remain of what once was. And sometimes, if we're very quiet and patient, if we listen carefully to the whispers of stone and sea and story, we can almost hear them, voices from a lost world, speaking across the millennia, reminding us that we are not the first to wonder, to build, to dream, or to lose everything and yet somehow continue. Sleep well, and when you wake, perhaps you'll carry with you a sense of deep time, of human resilience, and of all the stories still waiting beneath the waves, patient as the tide, ancient as the ice, quiet as memory. Thank you for joining this journey. Until next time, this is Worlds Beyond Seen, exploring the mysteries that lie just beyond our knowing.